Hello all, this is Diego. First of all, thank you for your comments and your questions. So I'm going to try to answer all of them. Just to give Amy a background, this is part of the Haiti project that has different parts. This is section B. Just to show you, these are the list of the deliverables. So one of them is to produce a potential rainfall productivity uh, in agriculture for Haiti. We completed section A, and so now we're working on section B. Then the potential productivity that we are working on is for maize and is based on WRSI. So the goal would be to produce a map of low productivity and high productivity for the different departments of level 1 uh, administrative units in Haiti. So to do this, we have the following data. We have end of season WRSI from 1982 to 2018. We have the agro areas obtained from the land cover map. And we have this table that we got from AID with production and in some cases yield. For the 2014 year, we have seasonal yield and planted area. So these are the growing areas, the agricultural areas by department, by level 1. We have this table that is giving us information on this the season in from 2000 to 2013 is giving us only annual information, and then on 2014 is giving us seasonal, and the annual information that is providing is just the production in metric tons, and in 2014 is giving us area planted and yield. But let's go to that table and answer the questions that Greg asked. In column B, these values, I should have deleted them because these values are the results of the WRSI average for each of the polygons. But the thing is, this was I didn't reclassify the late and the yet to start because yeah, I've done this many times, and at that moment I forgot to reclassify them, and I tried different ways of reclassification, but at this point for that, when I selected those values, I didn't reclassify it. So here we have values of 255 to 50, no, 253 to 54. So but then here, this is one where I reclassify them to 250, 253 and 254. I reclassified to 50. That was something that we did before, Greg. And then this one was the same, but I reclassified those values to no data. So we are keeping the WRSI values, and this is the productivity in kilograms per hectare, and that's the department. So that's how we are doing the analysis. So this is an example of the good and the bad years. So 2016 is a good year, 2014 was a bad year. Funk is concerned that we're getting too low of WRSI's values. So I need to check. So I'm gonna run this by hand on a pixel. That's gonna be the next step. What we're doing, so we run the WRSI for 82 to 2018. I had to redo all the input layers because they didn't cover completely the extent of the country. At the end, the WRSI product was too short to cover those polygons, the complete polygons that I showed in the previous slide. So I extract the agro polygons from the land cover and dissolve it by level 1 code, extract average WRSI for each agro polygon, level 1, and then build the relationship between WRSI and yield at the district level, and that's how far we got. The idea was to use that relationship or that model to convert WRSI to yield from the other years, and then have a 30 years history and establish high and low productivity maps from that. But then we got only to here, and this is the reason why. Department, this is the WRSI value, and this is the yield data. And this value right here on red is a hypothetical value because Harry found that in a good year, that means that we are assuming that 100 WRSI value could produce 850 kilograms per hectare. So with the data that we only have these 5 points right here. So we don't have any way to know what is the productivity at the high value of WRSI. So what we did is we put this hypothetical value that Harry found on the FAO website. Then we are saying if 100 WRSI, the value is around this. The productivity will be around this value. Then that would help us complete the spread of the WRSI values. So for this, well, so far we have these values right here. So then, or it's necessary to have a year that has good WRSI values so that we could see what kind of productivity that gives. So in conclusion, since we have a single year of data, we couldn't do much. So even though we have many years, we only have production, and we really need seasonal yield data to be able to relate it to end of season WRSI. And then yeah, the other thing is that 2014 was a drought year according to our WRSI, so that is giving us very low WRSI values. So it would be great to have either 2013, 16, or 2018 seasonal data so that we could complete the model.